Hello, I'm Neoc Hupcauk, your presenter today for Patterns on a Clock. Have any of you ever looked at a clock and realized certain numerical or mathematical patterns? Well, I have. Here's just a few of them to get you started while we work our way up to the big one. What's 7 plus 5? 12. 8 plus 4? 12. 9 plus 3, 10 plus 2, and 11 plus 1 all follow the same pattern. They all equal 12. Even 6 plus 6 and 12 plus 0. Pretty cool, right? Also kind of basic. So we're going to kick it up a notch. What's 1 plus 7? 8. 2 plus 8? 10. 9 plus 3? 12. 10 plus 4? 14. 11 plus 5? 16. 6 plus 12? 18. Those are all numbers divisible by 2, starting at 8. If you just add what I like to call clock opposites. Also pretty neat, but not like what we're about to get into. These are all additive. And while additive is all well and good, I'm about to get into some multiplicative patterns. And these are going to involve some math. So I was thinking the whole clock opposites thing was pretty cool, so I decided to follow this pattern. What if you multiplied two clock opposites? So let's start out with this. Now let's first assume that 12 is 0. What's 0 times 6? 0. Now let's go to 1 times 7. What's that? It's 7, of course. So I decided to keep doing this. Okay, so I've mapped out the products of the different numbers and their clock opposites. Pardon my very off-center lines, I'm not that good at that. So I decided to write down the equations and their quotients. 0 times 6 is 0, 1 times 7, 7, 2 times 8, 16, 3 times 9, 27, 4 times 10, 40, 5 times 11, 55, and 6 times 12. We're just going to say 12 is also 12 for this right here. We're just going to say that because it doubles us both. So 0, 7, 16, 27, 40, 55, and 72. I was thinking, okay, are these just some random numbers? Because they sure look like it. Or is there some sort of a pattern involved? Now, while it doesn't appear to be a pattern on the surface, this is math. And math is chock full of patterns. So I decided to do a little bit of investigating to see if there was, in fact, some sort of underlying code to these numbers. Okay, so I did the math, and I figured out that there is, in fact, a pattern. So 0 plus 7 is 7, 7 plus 9 is 16, 16 plus 11 is 27, so on and so forth. So these are definitely not some set of random numbers. These are all odd numbers, and they're starting at 7 and increasing by 2. So I've created a formula to map this out. N equals A plus 2, starting at 7. In this equation, N represents the number. This column are all... Sorry, that was my mistake. This column right here, this is N. Each of these numbers is N. And the basics go N, which is the number, equals A, which is the previous number, plus 2, starting at 7. So we start at 7. 7, now if you go to 9, 9 is N. If N is 9, and the previous number is 7, plus 2, the equation checks out. So, in short, what each of these numbers is doing is adding N, which again is one of these numbers is the previous number plus 2. So I don't want to make another mistake. So I'm going to conclude this video right here, and I'm going to continue this pattern, yes, it goes on, in my next video. So thank you very much for watching. Stay tuned for the next video. There should be a title card at the end of it, or a link in the description below, something like that. Remember this, n equals a plus 2, and until my next video comes out, look at some of your clocks and see, is there any patterns you notice? Thanks for watching.